Hey, hi guys. Hello all. Welcome to today's session. Myself Swayam. I have with me my other colleagues Pratik with us. We'll wait for some time. Let other members to join in, and we'll start shortly. Thanks. Hello guys. I think we can wait for 2 to 3 minutes more, and then we will start. All right, I believe it's a good time. We can start now. So, hello all, and welcome again. A very good morning, and thank you for joining us for today's session. This is our third meetup, which we are doing in collaboration with deeplearning.ai. And we thanks Indigene for supporting us in making this event happen. So the agenda for our today's event is MLOps, right? MLOps, machine learning operations for engineering and production. So basically, the idea and motivation for this theme comes, and we see that there is a huge need and demand for the AI, right? Applications, which is growing at a great velocity across different verticals. And we see with over time that the companies and the organizations have started realizing that they need to go and scale and take their research or experimental models back to the production. And that's where the time spent and the go-to-market strategies becomes very important. And it's the ideal need to optimize and unify your overall AI process flow, right? So overall, we see that there is a need for seamless and unified experience across various cloud offerings, because you may work or deploy with your model on cloud or on premises, which has to be constantly monitored and fine-tuned, right? So the scaling of ML and DL models from taking right from your prototype to the production and then deploying it becomes an integral part of your overall pipeline. So the idea of this session is that we'll talk and demystify about the AI workflows, and then we'll do an hands-on session and learn about the best practices to use while deploying this model, right? So this will help you in return get a proper idea, right? How do you plan and use industry proven architectures to deploy and build your models? So that's how the idea and the motivation comes along. And one thing before we continue, I would also like to share is that since this meetup is being hosted in collaboration with deeplearning.ai, so the team has sent us a video to inspire you all learners with the work happening in the field and how you can contribute, collaborate, and learn through these events and by the peer learners, right? So let's look into the video, so get some inspiration, and then we'll continue. Right? So I'll just play the video.
To give you a proper welcome, I'd like to show you around the deep learning.ai offices and meet some of the teams so they can see where it all happens. Oh, hi everyone. Do you want to tell our friends at Pine AI what you do at deep learning.ai? Sure. Hi, everyone. I make articles and other media that help people learn about AI, them understand the huge impact that AI is having in the world. Today, I'm putting together the next issue of The Batch, our weekly newsletter, and I'm looking for the biggest stories of the week to keep our readers informed. What's the most surprising thing you've run into working on The Batch? How much is going on in this field? There is never a dull moment. You might think from the outside that machine learning engineers really understand everything about AI, but nobody understands everything about AI because this field is just coming to life right before my eyes as I put this thing together. All right, I know you're ready for this, so let's get back to it. Thanks. See you later. Let's go meet Pierre, who helped me create the deep learning specialization. He's working on an exciting new project. Hey, Pierre. So, do you want to tell the people at Pine AI what you're working on? Yes, sure. I'm in a project for Muneer, focusing on what gets offers AI navigate their career by testing their skills, fine-tuning and certifying them, as well as matching and referring them to jobs. That's really cool. And what's the most exciting part of your day? AI is organizations and jobs are still misunderstood. So I'm excited to help people understand what different types of jobs exist, what tasks we work on, and what skills are needed to achieve those tasks. That's really awesome. That's nice chatting. And now, it's on their product.
I would love to. Hi, everyone. I'm the product team learning.ai. We're creating AI education content accessible to people all around the world. People like you.
And what are you most excited about right now?
I am so excited to see our community grow and to see how eager people are to learn more about AI.
Thanks also. So, as you can see, our team is working hard to support you and help you learn. It's definitely easier than before to break into AI. So, if you want to build a career, you can leverage online resources available, including open source code, data sets, papers, and online courses with deep learning specialization or courses. As part of this journey, I hope you get your hands dirty too. Don't be afraid of diving into build your own project, or writing an interactive academic research paper that you're excited about. One thing I've seen, common things I've seen, is that you can build a community or find a community of fellow learners you can meet with and study with on a regular basis. In fact, I hope that this Pioneer meetup that right now will be a good place for you to meet these people. I hope you enjoy the event today and that you learn a lot both from the talks and from each other. And once again, welcome to the Deep9.ai community.
All right, great. So this was an brief video from Dr. Andrew Ng. So you understand, right? The inspiration and the learnings. How do we gather, right? So that's where the importance of community comes, since the field is rapidly growing and new novel techniques is emerging day by day. So that's what mostly they wanted to show and talk to us. Going further, let's without further delay get right to our speaker one. So we have our first speaker with us, Muneer, joining right from Germany. So let's welcome Muneer. So to just give you a brief introduction about Muneer. So Muneer works with the NetApp. He works as an AI solution architect, and today he will talk and show some insights about the strategies and the architectures that eventually will help us to make AI projects manageable and consumable, right, by leveraging the latest MLOps and DataOps techniques. So I'll just give the access to Muneer and he can take it over.
Thank you, sir. Hope I'm audible.
Yes, Muneer.
Thanks. Let me share my slide deck with you guys.
I made you the presenter.
Thanks, sir. Just a sec, I'm getting. Okay, let me share my screen. I'm still trying to share my presentation deck with you all. Sorry for inconvenience.
No problem.
I'm still new to this GoToMeeting tool. I usually use Zoom.
Yeah. If you have issue, you can just share it with me. Will that be okay?
Let me do that. Yeah.
Yeah.
Send you the link. It's taking time, so because it's large file.
Okay.
Could you help me out with the sharing via this coordinating
Yeah.
platform?
Yeah. Just a second. Let me coordinate. Just give me a minute. Sorry, guys. I'll just take 2 minutes. Let us fix this. We'll be back. Just a 2 seconds.
Uh, Hi everyone, this is Pratik. I am a data scientist at Indegene and also the co-organizer at NeuronMinds.in. So Muneer is facing some issues. So meanwhile, we'll take the second talk that we have. That is Abhishek is. Abhishek is a senior architect at Medeva.io. So Abhishek is going to give a session on how he can work hands-on and to give you acquainted with how you can deploy the model architectures and what are the best practices and how should you maintain. So Abhishek, you are able to hear me?
Yeah, Pratik. Hi, hey everyone. I can hear you clearly. I hope you can
Yeah.
also hear me
So,
clearly.
yeah. So over to you, Abhishek. Go ahead.
Okay, I just need to present my screen. Just give me a minute. Hopefully everybody is able to see my screen. Let me zoom out a little.
Yeah, your screen is visible. Go ahead.
Hey everyone, this is Abhishek, and today I'll be speaking on how do you deploy the AI models and do the redeployment and maintain while after you have maintenance done on your uh, uh, ML models. So I'm software engineer at Medeva.io. I practice as a lead architect there, and let's start. Uh, So in today's agenda, we have these topics: understand what machine learning operations are, walk through some of the Docker concepts, and deploy a Flask service on Docker. Okay, so let's cover what MLOps is. So as you can see in the Venn diagram, MLOps is comprising of three main fields and which aims to deploy and maintain ML systems in production. Machine learning, no intro should be required to this. You feed the data to machine machine crunches the data with some algo, spits out the model. You use model to do prediction on future data. So main part machine learning. Then after that we have data engineering. The data engineering is about you do engineering on data. So how do you engineer the data? Machine learning processes involve getting the lot of data and validating that data that it is in a correct form, and how to maintain that data. All that stuff is done by data engineer and covered by the data engineering. And then comes the part DevOps. DevOps is what, as the name suggests, development and operations. So that covers a lot of things in the software life cycle, which includes like coding, where you maintain the code standard and mergeability of the code, and where everybody can collaborate on the code. For example, the tools include Git or SVM, and other processes comes under DevOps is building, testing, packaging, releasing, and monitoring. So that covers the complete ops or ML operations. Then let's move on quickly to Docker. Okay, what is Docker? Now, Docker is a platform which is going to help, which helps the developers and DevOps people to quickly release their applications and share their application with containers. Mind the word containers. That containers is the one which is the key part of Docker. Let's move on what a Docker container is. Okay, if I tell you, suppose you have to run your own program, and your program is completely isolated. You want your program to be completely isolated. Is like for every time you want to run a program, you need a new machine. Conceptually, you want to do it in a completely separate, every time I want a new machine. What will you do? You will basically containerize your application, which is completely isolated and which is going to run on another machine. And just imagine that there are tens of hundreds of applications like this, and they can run, every application can run in an isolated environment in a simple manner, and that will be running as a process. So that what a Docker container is. Then the next topic comes is Docker image. Now, when I say your container will be running in a completely separate isolated environment, that means there will be n number of things a simple machine has. For example, it will be having a file system, it will be having its own network and other things. So how do you define what exactly is going to be there in a container? That is done by image. You define an image, and in that image you define everything. Okay, this is my code going to be, how I'm going to get my code. Okay, I need to run finally a Flask application within this container. So I'll tell that in an image, this process will be running, and this is how we'll be interacting with this particular container. So that in a simple manner, Docker images. More formal definitions are there on the slide. And whatever I've explained till now, there is a pictorial representation of this. Okay, now if you see here, you have a container, which I said it will be completely isolated. You are running one app, and it's this app's binaries and libraries are totally available to this particular app within this container, and this is shielded from others, and that's what Docker is helping you. It's like you are getting a new machine for every it's just a on a conceptual level you are getting this. So you have container which is running app B, you have other containers, app A and app C, and those are running on the platform which is called Docker. Docker is running on something like host OS, which would be Ubuntu. Windows up to some extent supports host Docker, but mostly in production we go with Linux environments like Ubuntu, and below that you have infrastructure. So let's move on to how Docker helps ML operations. But before that, if anybody has a question till now, please ask them, because moving on further, after this we'll be moving on the hands-on session where I'll be showcasing a Flask app, being proving all these points which are covered by Docker. So please, you can ask any question if you have. Like, we can give 5 minutes for the question answers now, till now what I've explained. Pratik, Swam, can you hear me?
Yes, Abhishek. We are just waiting. If any question comes in, I'll let you know. Yeah.
Sure, sure.
So we can 2 minutes. We can wait for 2 minutes. If no questions, we can continue.
Yes, please. Sure.
Abhishek, I think we can continue.
Okay, fine. Okay, so here we are covering how Docker helps ML operations. Okay, now how will it help to containerize my application? Now, first point comes, okay, most of all applications may have most of the time have requirements of having different environments. So it provides you that different environments across models. For example, your one model has been is quite old and has been created using Python 2.7. Another, you have Python 3.5, and there are certain dependency which depends on the host. Like if you are running on a machine and there is only one dependency, C-level dependency can run on that machine. In that way, at that time you can't run these two models on the single machine. In that case, now Docker isolation comes into the picture and you can do that very easily. And there are other things like different library requirements are there. Suppose you have, for one you have TensorFlow 1.x, another is another requires 2.x. So that can also be done using that. And there are like different resource requirements are there. For example, one application can run on simple CPU, and another requires the GPUs. Now you can very easily control those things using Docker. Now, and a most important thing is which is covered by Docker is scaling. So scaling at model level. Suppose there is a model which can serve only 100 requests per second. Now, if you want to serve the request like 10,000 requests per second, then you will be needing like a lot of instances of that models. And what you can do, Docker can help you scale up the instances of your application. So, and suppose during this is now fixed number of applications or instances. Now suppose during a certain period of daytime there is more requests coming in and you want to handle all of them, so you need to scale out. And for that, what you can do, Docker can easily help you scale out during that day of time. Suppose you want 100 instances of the application during that time. What you can do, you can simply configure Docker to do that, and it will do that without zero downtime and give you the 100 instances. And then once you see, okay, the traffic is less, now you can reduce the number of instances of your application. And the last thing which is there is redeploy the model or your application with zero downtime. So all these are the points how Docker helps in MLOps. So let's see. Okay. So moving on to next is this hands-on session, which will be showing you a topic classifier application or model, which is deployed in a Flask application. So how I have deployed this, I have taken it from GitHub, and I have enhanced it to run with the multiple instances. So here, if you see here, the users connects to Nginx web server, which is acting as a load balancer, and you are running inside the Docker two instances of your application, or you can call two containers of your application, and in a round robin manner, whenever Nginx gets a request, it will either forward it to container classifier container 1 or classifier container 2. So actually what's happening behind the scene, Nginx is actually trying to contact Docker, and Docker is managing internally, okay, from which it needs to connect, which container it needs to connect for the response to be provided. So that's one thing. Currently I'm showing you for 2 because of the limitations present on the machine, and as per the resources you can make it even 1000, make it even 2000, and not on the single machines, but spread across like hundreds of machines. So that's how Docker is helping. Let me show you an example. So in Docker, what you need to do first is create an image. And how do you create an image? You have certain Docker commands in which you define what you will exactly be doing. So that is defined under a file called Docker file. So here we have a Docker file. Let me explain you as much as possible here what is going in this particular Docker file. Okay. One thing is that when you starting writing an image, or Docker provides you base images. So here your application is requiring the Python version 3.6. So we start from that image, and you get like a skeleton of your image. And after that, we are saying that, okay, from this current directory, copy the question topic app folder, and then your working dir. So whenever this application starts, you will land in this particular directory. So a container starts, and whatever will be happening, the first thing will be happening in this particular folder. And then you are saying, okay, let's make when the container starts, let's make this particular folder, make dir, and then install all the requirements which are there specified in this folder. So we have requirements.txt, and after that you are doing is basically downloading the sentence encoder and extracting it at the particular location. And then you are saying, okay, my app is going to run on port 5000. So I want to tell that, okay, this on this port you should be able to listen. And in the last, you have like running your Python Flask application. So you give a command python app.py. After this process, you simply build an image, and building an image is quite easy as running this particular command. I'll not be running this command in front of you because it takes around 5 minutes to build the image. So here I can explain you. You simply say, okay, I have given you how the definition of image. Now please build an image for me. So Docker build, you are providing -t is tag that, okay, I want to keep it as a name question topic. The image name is going to be question topic, a particular version which I can tag with any name. So I'm giving here the number, giving here that tag as test. and dot is the current directory. Let's look for the Docker file in this particular, in the current folder. So that's how you do. Now, what I'm showing you here, what I enhanced in this particular application is the deployment part. So there is Docker. On the top of Docker, we have Docker Swarm, which helps us to deploy or orchestrate the whole deployment on in a distributed manner, and through that we can achieve like parallelization or scale up and scale down things. And let's see how it is happening. Okay. So to define how Docker Swarm is going to orchestrate all this, we define a file called Docker Compose. If you see here, here I'm defining first thing is version. Then there is a service which I'm naming as question topic. So you are going to tell it, okay, which image it is going to use. So what I'm doing is here I'm using this particular image I'm using, and after that you tell it, okay, how many instances you are going to run for this particular application. So we are running here, we are saying please take 2 instances, and there are other things to be configured. So it is deployed in on the server, and here I can show you how it is working. So let's just again send the request. Okay, if you see here, we have the ML input as these questions, and it is giving us the output as, okay, what could possibly topics percentage, and for each question we have asked. And just mind that I have mentioned another argument here, which is being written in the response, is the host name. So this host name I have included because to show you that from which host or which container, every container is provided a host name from which container the response is coming. So if I press the send again, since we are running 2 instances, so the host name might or might not change depending on from which container we are receiving the response. Since it's in development mode, it is little slow. Okay, mind that the host name changed. So this is how you are achieving the high availability and running the multiple instances of your application. Now suppose this point, other than this, you have now done, you have observed your model on the production for quite some time, and you have made some improvement. You are in maintaining the model, and now the new model is ready. Now since for you, deployment of the model should not be giving any downtime of the application. How can we do that? So for that preparation, for showing that, what I have done, I have another version of this image ready, in which I'm adding one more param to the response, and that should be available without any downtime. So let's achieve that. So for that, what we need to do is only do this. Let's change. I have the another version of the image ready, and we can simply change that 0.0.2, and I simply run again the same deployment. And if we see, let's it is updating. While updating, let's see if the application is down or not. So okay, we are getting the bad So here, if you see, I have one more thing added, which is comment. So that's how you are actually scaling up your application while running. So since we got the error in between because it is running on a single machine, and that's why there was a little downtime. But if you do it on the when there are n number of machines added in your on your Docker swarm, this will not be a problem, and your user will never see anything as a downtime while using the application. Of course, the changes will be shown, whatever changes you want to show. So that's how you achieve the ML operations using Docker in a swarm method. And that's it from my side. So these are the resources which I took everything from. And thank you, everyone. And if you have any questions, please ask.
Thank you, Abhishek, for such an elaborative discussion. Manjunath, do you see any questions from people? If we have, we can take up.
There are no questions.
Okay.
Oh, okay.
So thank you, Abhishek, once again for giving up your time. And next, I think Muneer is ready, all set to go. So Muneer, you there?
Am I audible?
Yeah, you are.
Can you see my screen now?
It seems like black.
It seems black. Let me...
Yeah, now something is visible with NetApp.
Is it a presentation? Can you see the presentation?
Yeah, we can see the presentation.
Perfect. Thank you so much.
Okay, over to you.
Thank you. Good morning, everyone. Apologies for the inconvenience. I'm kind of new to this GoToMeetings. I usually use Zoom and other platforms, but GoToMeeting was my kind of my first experience. Sorry for that. So moving forward, so I'm Muneer. I'm working as AI solutions architect and data scientist by profession at NetApp, covering Europe, Middle East, Africa. So mostly when I talk with my customers regarding different projects, so I deal with different verticals like fintech, automotive, healthcare. And every time what I see is that these customers and these projects are struggling, like 60, 70% of them going to production. We see a lot of research going on, like over the time from 2010, 2012 onwards. We see exponential growth when it comes to research, publishing papers, but very less projects see the sunlight. That means go to production environments. So this talk, we will be discussing or we'll be demystifying AI workflows that are needed to take these projects to the next level, that is making them usable and consumable. Abhishek in his session mentioned a lot about how do we serve properly these models using some techniques like Docker and then a Docker Swarm for orchestrating these whole containers, bunch of containers out there and making it easy to consume. So one of the good applications out there that you guys can utilize. In this session, what we will do is we will dig deeper into the end-to-end workflow. What I mean by end-to-end workflow is literally starting from where my data is coming from, how do we curate that data, make that available for my trainings, and ultimately deploy that in the production server. So generally what I see out there is we have, I categorized it as a general AI workflow. General in a sense, it can be utilized in different verticals, different use cases out there. Definitely needs a little bit of, let's say, modification based on the project itself. So of course, without data, we don't have any AI applications out there. My AI model is gonna be as good as my data. And it always starts from getting data from somewhere, like ingesting. It can be IoT devices, it can be log files, It can be unstructured data as image, or it can be videos. So multiple data, sometimes very complicated in a sense that getting them together from different sources, like sensor data. Take an example of autonomous driving, where sensor data is interacting with other sensory data. For example, image sensor data is interacting with LiDAR and other data out there. And when we train our models, we take care of all those things and create a model in such a fashion that can understand different, you can say, data ingestion and formats as well. So that's where this green bubble comes into picture. Do some data transformation analysis. Analysis is important when we get started to know whether this data can be utilized at all for training models. Once we had that, what we see over there, we usually start a small training. Let's say take 5 or 10% of the data, because in industries, when we talk about data, we talk about terabyte and petabyte scale data. And directly starting using all the data is not a good option, or is not a good for a company in terms of time as well as investment. So they usually start small projects like 5%, 10% of the data, and do train test separate to see everything is working. And meanwhile, monitor everything. Like when we started the project, business use case, is it solving that business use case? And here, define matrix, like what we're going to be using, on what basis we will say that my model is performing as expected. You can take accuracy, you can take AUC, ROC, other scores out there. So that will be defined in this phase. And finally, in research domain, our projects are done here only. We write papers, like what I used to do before 2-3 years. We write papers and select the cherry pick results, because papers is like what I write, and that's going to be accepted in that fashion. But in real world, it doesn't work like that. We had to go to scale. We had to do training at scale, because go to market is important. Time to market is important. How much time it takes for us to create those products, and as well as update as we go. And as I mentioned, data is in petabytes. So we need to train at scale. Not 1, not 8 GPUs are going to cut that. We are going to be using clusters of GPUs, hundreds and tens to hundreds of GPUs out there. And usually it's complicated in a sense that you have to take care of managing all the resources yourself, how my data is going to be distributed, how my models are going to be trained in a distributed fashion, like you use Horoword and other tools out there. So they had to be taken care properly. And ultimately, these models go to the production. We roll out, we serve, and rollout is an important thing as well. As Abhishek mentioned, we don't want our customers to see any downtime over there, because these applications are going to go live and users are going to interact with these applications. Take an example of any online shopping cart. So online shopping cart cannot have downtime of 1 or 2 minutes. That means they're losing customers. So it should be smoothly rolling out of different versions of models. And ultimately, only thing that's constant is change. So these models are going to drift with time. Maybe data distribution is changing, or some different behavior is happening that was not seen by our models, like this pandemic. What happened to stock market before 1 year is completely different what we see today. So model is going to drift. So we have to take these changes into consideration and start the process again, go back, update these different models as we go, depending on the data, depending on the circumstances. Sometimes we might have different models coming that are better than the previous one itself, like BERT, then GPT, and all those things. So we can update, or we should be able to update it. And it can happen on different sites. What I mean by sites is I can start small POC in the cloud because it's easy to set up, and I can just spin up instances as we go. But down the line, it's very costly for the company if we consider total cost of ownership, and some of the customers go back to on-premises. Now, the challenge associated with that are, if our models are architecture dependent, it's locked in. So we cannot move to different cloud vendors or on-premises, or in my laptop if I want to test it. So we have to be sure that it can be accessed wherever and whenever we want. Meanwhile, guys, if you have some questions, some feedbacks, please just write it down in the question section so that we can answer your queries at the end of the session. As you see that it's pretty complicated, different processes are involved and different team members are going to be working on these projects. And usually what we see out there is people prefer to go with Jupyter notebooks or similar kind of solutions, which are meant for rapid application development, but never for production ready solutions due to obvious reasons. First of all, manageability. How do you manage it when we are rolling these in the production environments? Testing your solution from software engineering perspective, as well as models, integrity, and accountability perspective. So that's why we need some kind of optimization to kind of manage our whole AI workflow where different team members are working. Like data processing, data gathering can be handled by data engineer, having different background, like coming from statistics, coming from mathematics, and data science piece like developing models can be some guy who is having a domain specific knowledge little bit, let's say someone from healthcare, biomedical guy, and knowing the software engineering so that he can design these models. And finally, deployment of models is being taken care by some DevOps guy. So they're coming from diverse backgrounds, and what we need to do is create some kind of workflow that they don't need to understand much about their language, but at the same time, they work it together. So this is the scenario what happens usually. So you start from your small workstations, and you can go to the training rig. Training rig can be tens to thousands of your GPUs, and you can use sometimes cloud as well. And you have different architectures. Like I can use, right now I'm using Mac, but I do training on Ubuntu, and in cloud, I sometimes use a Windows platform. As I mentioned, it's a different platforms, different software stacks out there. So what we usually see is we go towards containers. One of the reason, as Abhishek mentioned as well, it's portable. If it's working on my laptop, it's definitely gonna work on my training rig. But when you have multiples of containers, it's difficult to manage. How do they communicate, services, networking, all that is basically not solving a problem, but adding more problems on top of that. We want a scalability, we want a portability, but we had to consider cost that is associated with it. So Kubernetes is one of the solutions that is handling and orchestrating all those containers without user need to manually manage those containers themselves. But as we all know, with containers, our containers are designed in such a fashion, once my job is done, all the resource that was associated, that means my storage as well, my data as well, is gone. That's how it's been designed, so that all the resources go back to the pool and other containers and other applications can utilize that. But for data science, we need persistency. If my data is gone, you can say, like as someone mentioned, that data is gold. My data is gone, my model is worth nothing. If I want to roll back to the previous version, I don't know what data I use, what model was trained on that data. So for that, we are leveraging NetApp Trident. It's an open source plugin that is creating volumes and making them persistent on demand basis. That is, if I just need some terabytes today, but tomorrow data is getting more and more ingested. So I should be able to dynamically change it. So that's been taken care by Trident. On top of that, the beauty is that you can use different frameworks of your choice once platform is up and running. We don't need to redesign anything from scratch. I like TensorFlow 1.5, tomorrow I go to 2.0, or I change to PyTorch because they are providing me some good wrappers on top of that, like fast AI. Or I can go to Chainer. Completely depends on the user because it's container based. But still, one thing is missing. If we see that workflow is still being handled by guys itself. So for that purpose, having that transition automatically, once data engineering part is done, it should automatically kickstart training. Once my training is done, it should automatically deploy my best model in the production servers. And for that purpose, we have different tools. Like one of them is Kubeflow. So Kubeflow is basically, it's based on Kubernetes. It works on top of Kubernetes, but at the same time allows data scientists, data engineers to just forget about that you are using Kubernetes, you are using containers. Just bring your script and it will automatically create containers for you on top of Kubernetes, do scale up, scale down, auto healing for us. So we just need to, as a data scientist, I just need to focus on my KPI. That is bringing intelligence to machines rather than managing infrastructure and all those things that is not directly part of my project. And usually the additional stuff that we see is 70% of the total time that data scientists, data engineers spend, rather than main job, they spend only 30%, because they are investing time in these menial things. And Kubeflow helps over there as well to automate it as much as possible. One of the use cases that I would like to proceed with is financial time series. I like the use case in a sense that it shows both that real-time data flowing in, like transactions, millions of transactions per users doing, as well as you have historic data that you can leverage to make your models better. And with new data coming in, you can modify your trained models and make it much user centric. So one example is I'm using historic, like stock close value. Is for the stock values, like what was the closing value of that stock over the period of time, and we're trying to predict what is going to be the stock value in near future. As I mentioned, data consolidation part consists of real time, that is flowing in transactions per, how many transactions are happening and what's been there. And in this case, it's just a stock value, close value. So real time, every day you get that stock close value at the end of day. And historic, you can take 10, 15 years of stock value available. Definitely, you need to prepare and curate data in such a fashion that our models can understand and we can train our models. Finally, do some training and validation on those models, whether my model is behaving as we expect, and deploy these models in the production. Best trained model and monitor trained models. So monitoring trained models is important as well. As I mentioned, there might be some model drift, data distribution is changing over the time. So we need to trigger some kind of, let's call it event. If some event is happening, we are expecting results, let's say close value, my model is predicting that tomorrow stock A is going to be having close value of 10 euros. But it's been now, my model was wrong. If I check tomorrow results, it was just 1 euro. So that means this is time to refresh my model training. And data provenance and machine learning versioning. So we usually skip data provenance and ML versioning because this is not coming from software 1.0, that is traditional software engineering. And machine learning development is a little different. It's all about data. So what data I used, if I change just 10% of my data, my models can behave drastically different. So not just my code, not just my configuration matters, but also what data I used, how it was curated, which pre-processing methodologies was leveraged, and ultimately what model was produced. So whole data lineage or data history is really needed to make our models auditable, as well as preserving the whole life cycle so that we can retrieve or we can go back in time to see what models were trained on what data and who was using those models at that time, or applications as well. What model consumed that? What application consumed that model? And in Kubeflow, how we do that is this is one sample of pipeline in the Kubeflow, how it looks. So each of the component here is basically Kubeflow is creating automatically containers or leveraging containers for us. You have still to create those containers, by the way. You have to create image for example, here I'm downloading automatically data from Kaggle to get all the financial time series data, and then consolidation of data. So consolidation is going to be one more component. Internally, you had to create a container for that yourself, and then I'm processing some data. You can add few conditions, like if my pre-processed data is still, let's say only 10%, we are expecting thousands of entries, like 1,000. If I'm getting only 10 entries, I'm not going to train my model. I'm going to scrap more data. So you can add conditions here as well. And you'll get pretty managed UI there, like what happened to your accuracies with models. You can add different hyperparameters, and it's logging everything here. Rather than I'm creating my Excel sheet and writing what accuracy I got today with model A, having data set ABC, it's logging everything for us. But what about the whole journey? Like I talked about, you have to create containers, you have to write code and all those things. But as a data scientist, as a data engineer, do I like creating containers? Do I like understanding how it's going to behave with Kubernetes? Not, because that's not my KPI. It's just a waste of time for me. That's why most of the data scientists, data engineers stick to Jupyter notebooks. As I mentioned, that's just rapid application development tool. So let's walk through that together and see how we can make it much better. So as I mentioned, writing code, building pipelines, because you had to build container image for these tests and approvals, you're writing code. So not your models only need tests and approvals, but your code as well. Sometimes accidentally your code is asking for thousands of GPUs, and your administrator is not going to give you thousands of GPUs. So some checks are needed for code as well, not just model. A data and model versioning, as I explained earlier, data provenance is very important. Reproducibility and shareability. If I'm writing some code today and tomorrow I'm leaving company, my model and my whole AI workflow should be taken care by my colleague. Or if we are working 10 folks in a team, how do we share properly so that we can hit the goals on time and there's not going to be overhead just by managing? We're communicating with each other using Slacks, using emails. It should be automated. And tracking events, like my training has been started, my training is completed. So I'm kind of a guy like checking my training models every 5 minutes, every 10 minutes. If I get some event like my model is drifting, you need to stop, or my model is not behaving as I expected, that would save a lot of time for me as well and other data scientists for sure. And model drift, once my model is drifting, give me an event so that I trigger model training again or get more data. And these things we need to address properly and efficiently so that our projects are not going to fail down the line when we had to roll out these models. That's where MLOps and DataOps comes into picture. So MLOps and DataOps are basically methodologies, not just tools, but methodologies and mindset which we have to adopt in such a fashion so that our models are going to take these concepts into consideration from the very beginning. Because once my model is out in the market, it's going to be difficult to start from scratch and adapt some of these methodologies. And MLOps, DataOps is still evolving. And the concept here is start from, like, take always into consideration where your data is coming from, how you would like to process that, how you would like to train it. It can be one single model, it can be billions of models at the end of the day. And how do we want to deploy that in the production? And it should be automated as much as possible. Now, to leverage these, we have some tools out there. So you're leveraging some of the traditional software engineering tools and adding some new tools from AI realm as well. Code versioning we all are aware of, like GitHub, Bitbucket, GitLab, and AI workflow. I just explained today Kubeflow. We have others like Apache Airflow, you have MLflow, and other tools. I'm just mentioning open source. There are other paid versions as well. And for CI/CD, of course, no introduction needed. You have Jenkins, Circle CI, TC from JetBrains. But one thing that was not directly part of traditional software engineering is taking data management as part of your pipeline. And for that purpose, definitely I'm from NetApp and NetApp is paying me. So we're going to be taking care of NetApp ONTAP AI for AI data management. And going forward, we'll discuss how you leverage code versioning using GitHub, Kubeflow for AI workflow management, and for CI/CD, Jenkins. And for the data management, NetApp ONTAP AI data management platform, which is having certain features that I would like to point out. First of all, Trident we just discussed that briefly in the first 2 slides, for persistency and on-demand database volume provisioning for our containers for our Kubernetes clusters, and model versioning and data versioning using NetApp snapshots to have data provenance, and also cloning. Cloning is let's say when we are talking about traditional software engineering, there we were always taking into consideration that we're going to be having test bed, then we move to staging, then go to production. Why don't we have similar concept for machine learning as well? Because it's a little complicated. Not my code or configurations. I need to take care of data as well. Because in test, I can add or I can do some pre-processing that is not needed in the prod, or that's not needed in the staging. So I have to be cautious. What I do in the data, it might reflect to different environments as well. With cloning, it's basically definitely, like as its name suggests, it's creating the clone of the data itself, but only different, like test, staging, prod is only gonna store delta of that. Like parent copy is gonna remain same, only afterwards changes are gonna be written to different copies. So no one is messing up with the data of any other platform. and it's cloud connected. So if your model works on premises, it will definitely work in the cloud without user needing manually moving data from here and there, creating syncs. It is automatically doing that for us. And cloud compliance like fintech or healthcare data, where compliance is of utmost importance. So it's providing those compliance reports out of box. And everything is connected with this cloud sync. That means if I'm doing some update on premises, if I allowed that, it should affect or reflect in my cloud setup or any other premises as well. It's automatically leveraged. So that, think about, I want to train my models on premises, but I want to deploy my trained model in cloud where my application resides. For example, shopping cart that I'm leveraging AI for recommendations, that resides in the cloud. But training, I want that on premises because I have lots of GPUs. So these things help us to automatically deploy that to different sites without users manually moving data here and there. And doing so, it's leveraging and managing the whole life cycle of the data. So we can definitely track if my model A is right now in the production, what data was used. If it's 1 year, 10 years back, definitely we can go back to the time and see what data and what code was used. Now, these are just a bunch of tools, but how they work together, kind of orchestration of all the tools. So let's start from the data scientist journey. So data scientist is going to push code, like whatever I'm writing today. I'm writing a model on this Inception, Inception v4. I push that code. It goes to the Git, normal flow, nothing fancy. And this data scientist is going to create a merge request, and that goes for the approval. It can be chief data scientist or head of the project. And once he or she is going to approve it, we go to Jenkins, and Jenkins will automatically trigger, build our pipelines, build our models like containers. So as a data scientist, I don't need to take care. I don't need to worry. In fact, some Docker is there. I'm just going to write my code and it will automatically build everything. Definitely, there are going to be checks in place where the code is as we expect. And Jenkins is automatically also going to trigger training, like do the data consolidation, gather data from different sources, finally train my model. And after training, we're definitely going to be getting models. And we cannot directly deploy these models. We still have to do some tests. One test can be matrix. So we can set, like, if 90%, my model is getting 90% accuracy, then only deploy. And it still goes, this Jenkins is going to create one more merge request for the model, which is going to be approved by, again, head of department, chief data scientist. Once he or she is going to approve it, it's going to be deployed to our model serving. So model serving can be, there are different, you can say, ready to use solutions like Selden. We have TF serving, we have KF serving. So these are designed in such a fashion that you just have to bring your model, APIs will be created for you, scale up, scale down, those features are being created for you. In fact, you can serve multiple versions of the model, like 1, 2, 4, up to you. And you can decide on the runtime which version you would like to use. You can deploy multiple models as well, from like one for object detection, one for segmentation. So for that, I don't need to write a single line of code. These serving engines are taking care of it. And from the data piece also, as I mentioned, we need to leverage data versioning, cloning. So we always start, like in this project, I always started with the Trident to store my data as well as my models, and take the machine learning versioning of it, like snapshot of it. Snapshot is basically point in time capture of that state with data, with code, with configurations. Once we have that, we can roll back. Also clone the whole setup. I'm creating test, dev, and prod here, having all the code, data as well, copies. It's not a copy, as I mentioned, we're just storing chains afterwards. And connect it with different cloud providers on premises, like in a hybrid fashion, whatever I want. I want to use my laptop, and tomorrow Google Cloud, and the day after AWS, it will work. And just for the fun, so I also integrated Teams with it. Like when my Jenkins was creating these jobs, I was getting a notification that my Kubeflow run has been created. I can click on this link and I can see the status, what is happening to my training here. Like pre-processing is, this green tick means it's done. Like pre-processing is done, models has been created, training is being now done. And afterwards as well, I'm getting one more notification that my training has been finished, I can check now logs. So you can automate on top of it as well. So key takeaways here. First, leverage CI/CD pipeline. If it's just a simple one, do it, because down the line it will make your life much easier. You will save a lot of time. It's a component based. That means if you want to just change your pre-processing, that's not going to reflect your training. That's not going to reflect your model deployment, or other way around. You just want to change training component. It's not going to reflect your pre-processing. So you can use these modules in next project as well. So it allows change to be more flexible. Monitor and update. I cannot stress more, like monitor, because change is the only constant. Your data is going to change. New models are going to be coming up. So you have to take these things into consideration. Tomorrow, if I have to update something, how easy or how difficult it's going to be. Data lineage and lifecycle, as I mentioned, not just to go back time and see what data you use, what model was produced, but for the auditability purpose. Let's say, as per this EU standards, you have GDPR, General Data Protection Regulations. So if my patient today is allowing me to use data for some medical imaging diagnostics, and that patient is telling me after a year that you are not going to be using my data anymore, I'm taking my rights back. How do I make sure that his or her data is not being utilized, the model that is being in the production, trained on that data or not? How can we make sure? So keeping track of those things are really important as well. And hybrid multi-cloud. Hybrid multi-cloud is a growing concept. The reason is some of the services are provided only in the cloud, like you have Vision API from Google. You have other tools from other cloud providers. Sometimes we would like to leverage that because it saves a lot of time, but we don't want to get stuck over there. So having this hybrid multi-cloud setup helps a lot from cost perspective, from being more flexible, as well as saving time to the whole project lifecycle. With this, I would like to say thank you all, and may the AI be with you.
Thank you, Muneer. Thank you for this collaborative discussion. And thank you for joining at this time when it's too early for you. Many thanks for joining us.
It's a pleasure.
So, yeah, so now we have a few questions from the audience. One is for Abhishek. The person is asking how we scale up to multiple machines.
Okay. So scaling up to multiple machines, Docker Swarm, or as I didn't cover mention about Kubernetes. In both, they provide you certain ways to add multiple machine. Like in Docker Swarm, there is a concept of manager and worker machine. So what you do, you either add it as a manager or worker machine. It gives you a token, and that machines all the machines should be able to talk to each other, and using that token you issue the commands and machine gets added to that particular cluster, Docker Swarm cluster. Now once the machines are there, now it's the job of manager nodes to distribute the application instances on multiple machines. You can also control on a part if you want that okay, that application should be deployed on these kind of nodes where the resources are these much, GPUs must be available, for example, and the network speed must be this, storage must be these. All these kind of configuration you can do, and all that is specified in Docker Compose file. There are lots of declaratives are there which you can do in the Docker file, and using that Docker will scale out your application. I hope I covered that. I am able to answer the question in a fine manner which you can understand.
Audience, please, you can comment if there is any other question or there is any other clarification required. Meanwhile, there is one more question that is for Muneer. How one can selectively roll out models? For example, if somebody has a new model, he doesn't want to roll out this model to only all the customers, but only 10% of them. And how should he observe his behavior?
Yeah, that's a great question. So usually what we do is we call it as a canary deployment. And in canary deployment is that we have some previous model, let's call that model A, and our new model is model B. But we are not yet sure how it's going to behave in the real world when real data is coming in. So in canary deployment, what we do, we have, let's say 10% of the traffic going to the model A, that's the old one, and 90% to the new one, so that we will monitor the behavior in the real time. And once we are satisfied with our new model, all the traffics will be flowed to the new one. And these approach, as I mentioned, we have Selden for serving engines, we have TF serving, we have Kubeflow serving. So those serving engines are automatically taking care of that. So you have a YAML file like a declarative where you can mention that model A select a traffic of 10%, model B give a traffic of 90%, and automatically it will take care of your model, traffic handle. And you have a zero downtime there as well.
Okay, thanks for the explanation. Manjunath, Swam, do we have any other questions from the audience?
That's it.
Okay, so I think we are into the end of the session. Thanks everyone for joining. Swam, do you have anything to add on?
Yeah, so it was a great learning. So I believe everyone have got some key takeaways from the sessions, especially towards the MLOps, right? So this is the key trend happening and towards the engineering and production. So it was a great and great to have such lovely speakers giving us such informational sessions. And I hope you all liked it and enjoyed it. So what we can do, we can conclude the session here now. And you guys can have a happy weekend and happy Navratri. So see you all next time. Thanks for joining in.
Yeah.
Thank
you everyone for joining. Thank you. Bye everyone.